Hello everyone and welcome to another AdMaths tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 8 Probability Distribution, Long Question, Example 3, Part 1 video. Okay, in this Part 1 video, I'm going to discuss the overall notes of the normal distribution, guys. Okay, the reason I come up with this video so that for the upcoming 3 videos, you will able to understand the question better. Okay. Before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Alright, let me start to discuss the normal distribution notes now. Okay, what is actually a normal distribution, guys? Okay, a normal distribution is actually a probability function that describes how the values of a variables are distributed, and it's also known as a bell curve. Since the graph is look like a bell shape over here, so most of the time you'll call it as a bell curve. Okay, it's easier, okay, rather than calling a normal distribution. Okay guys, so this is how your graph looks like. Okay, let us look at the formulas that involves in the normal distribution. Okay, these are the formulas that involves in the normal distribution, where you can take a look over here. Z is equals to x minus mu divided with sigma. So what does this mean, guys? Okay, let us take a look at the variables now. So Z is represent the Z score, which is represent at the standardized score. So X is represent at as the value of a normal random variable. Okay, this mu symbol is represent as the mean of a normal distribution. And at last, sigma is represented as standard deviation of normal distribution. Okay, so these are the respective meanings, guys, behind these variables. Okay, now you might be asking me a question. So why we need to change it into a Z variable? Why we always need to change it to a Z score? Okay, let me give you the explanation now. Okay, most of the time, this application of the probability distribution is mostly rely on the normal distribution, guys. Okay, mostly in the companies, they'll be using the data over here. Okay, they'll be calculating sets of data, and then they will plot in a graph such a way that fx versus x. So this is how your reality will looks like, guys. So to calculate this probability, sometimes it can be very difficult since we don't have the definite function over here. We don't have a proper reference on how to calculate a probability, the area under the graph. So what the mathematicians do, they convert this probability distribution graph into a standardized normal distribution, such that whenever you have your particular data, you can convert this probability distribution graph to standardized normal distribution, which is the Z term, so that anyone can use this bell curve to calculate the respective probability, provided that you have the sufficient information such as the x value, the mu value, and the sigma value, and the respective x values, guys. So this x value will later on will be converted into the Z score, and this Z score will be useful as the area under the graph. So what is the area under the graph exactly I'm talking about? So please hold on, guys, I'm going to talk about it soon. So as you can see over here, originally this is your bell curve, guys, which is your probability distribution graph, which is in the normal distribution graph. So from here you convert into a standard normal distribution. So this is the bell curve. So where your bell curve starts at the 0 over here. So this 0 is actually your mean value, guys, and this is your negative region, and this is your positive region over here of the Z. So these are the explanation for the normal distribution. Okay, let me turn to the next page. Okay, now I'm going to explain to you the general steps on how to solve a normal distribution question, guys. Okay, the first step what we need to do is we need to identify the mean mu and the standard deviation sigma. So these two information are crucial, guys, whenever you want to calculate a normal distribution. Okay, this is the first step. So the second step, what you need to do is you need to find the respective Z value based on the given X value or X values. Okay, why I mean by x values over here, so please hold on guys, I'm going to explain to you in a later part. So once you identify the x value, the mu and the sigma, so the third step is you need to draw the bell curve. Okay, you need to draw the bell curve, and then from there you need to find the probability of the respective z value using the standard normal distribution table, which is also known as the z table. Okay, if you haven't looked at the z table, okay, let me show it to you how a z table looks like. Okay, so as you are looking right now, this is the z table guys, the upper trail probabilities qz of the normal distribution. So this is your z table over here. So from here you have the respective z values start from the 0 and up to over here is 3.9. okay, so you have a wide range of z values guys. So this table will be very useful for you, so you make sure you should know how to read the z table over here. But if you don't know how to read so far, no worries, I'm going to teach you how to read the z table guys, so please hold on for a moment. Okay, so let us proceed to the next part of the notes. So now we're going to go through how to read the z table. Okay, in this series of the how to read the z table, I'm going to discuss 5 possible questions on how the probability can be asked. So let us start. So as you look over here, so this is your one of the bell curve, and your one is shaded at the, your z is equals to 1 is at the positive side and is shaded at the right hand side region. So what does this actually mean guys? Okay, this actually means that your probability of z is actually more than 1.0. So how are we going to calculate this? Okay, let's say you have already calculated the mean and the standard deviation and the x, and then you end up getting z is 1.0, and the question, let's say they ask you to find the probability such that the z is more than 1.0. So from here, how are you going to proceed? So it's actually very simple guys. Okay, let me show it to you the working. Okay, let us do it together. So from here, what you do, so the probability z more than 1.0 will be equals to upper trail probabilities value, which is 1.0. So why q 1.0? This q is based on the table value guys that I've shown to you just now. So this 1.0 we're going to find it using our z table over here. Okay, let me show it to you how to find it. Okay, can you see the at the left hand side? So this is your z value guys. So can you see 1.0 somewhere else over here? Okay, if you look closely, so this is your value of 1.0 guys. So your 1.00 is actually 0.1578. So this is your area of your probability guys. So it's that simple actually. So q 1.0 is actually equals to 0.1578. So this is your answer. It's quite straightforward. Alright. So this is one of the easiest example they can possibly ask you guys. So given that your z value is more than 1.0, what you do, this z value you convert into the upper trail probabilities, the qz. In this case your z is 1.0, and then what you do, this 1.0 you immediately you find it using the z table over here, and then from here you get your 1.0 is equals to 0.1578. so this is your respective z value. Okay, so this is one of the simple example. Okay, let us proceed to the second example now. So this is your second example. Okay, your second example, instead of in the positive side, now it's shaded to the negative side over here. As you look over here, your z value is now negative 1.0 and then it's shaded to the left side of the region. Okay, so what does this mean, guys? Okay, this means that your probability of Z is actually less than negative 1.0. Okay, so you have to find the probability such that your Z value is less than negative 1.0. So from here, how are you going to proceed, guys? Okay, let's say you find your all the respective mean value, standard deviation value and X value in the question, and then you end up in this case. So how are you going to proceed from here? Okay, so from here what you do, so probability of Z less than negative 1.0 is actually equals to upper tail probabilities of 1.0, guys. It's the same. Okay, so from here, probability of Q, upper tail Q 1.0, we have already find just now is 0.1578. So from here, the answer is actually the same, guys, which is 0.1578. So this will be your answer. Okay. Regardless your X, whether it's in the positive side or the negative side, you should get the same area under the graph, guys, because your area under the graph is a scalar value, is a positive value. So from here you get your area under the graph, which is 0.1578 for the positive side, and then for the negative side you also get the same answer, which is 0.1578. Okay, by the way, guys, for your information, this value stands for the probability value, guys. That means 0.1578 when you convert it into 100%, that means you have 15.78% chance such that this event that might occur. Okay, so this is the second example. Okay, I have 3 more examples for me to discuss, so please hold on for a moment. Okay, welcome back. So this is the third example I'm going to discuss. So if you meet in this case, so how are you going to solve, guys? Okay, as you can see over here, you have your Z table is 1.1 is in the positive side, but then instead of shaded in the right hand side, is shaded through the whole left hand side. So from here, how are you going to continue? So in this case, the probability they ask to find is probability such that your Z is less than 1.1. Okay. Okay, let me tell you one tip for you guys. Your area under the graph, the total area under the graph is actually equals to 1, which is stands for the probability value, guys. The 1 is the maximum value of a probability value. Okay. But then if you look at the table over here, the maximum value is given to us is 0.5, which is exactly at the 0.0 over here. So from here, how are we going to proceed? Okay, let me teach you guys how to do this type of questions. Okay, so from here, the similar step, but then what you do, instead of writing directly the Q1, now you minus with probability Z more than 1.1. So this is how your answer will look like. So 1, you minus your probability such that your Z is more than 1.1. So from here, the area under the graph, which is your 1, and then you minus with this right side shaded region, so you get the whole left hand side. Okay, proceed to the next step of working. In this case, you minus with the upper tail probabilities Q 1.1. So this 1.1 we need to find in the Z table, guys. So equals to 1, you minus with, okay, if you look in the Z table, 1.1 is actually equals to 0.1357. Okay, so this is your respective Z value, 0.1357. Okay, you calculate this. Okay, let us calculate this together. 1, you minus with 0.1357. So from here you get your answer 0.8643. So this will be your answer, guys. So from here you get your probability is 0.8643. So this will be your final answer. Okay, this is the third example. Let me proceed to the fourth example now. Okay, let us take a look at the fourth example. So this is how your fourth example might look like. So instead of the positive side, now your z is in the negative side over here. So from here you get your z value is negative 0.75. Instead of shading at the left hand side, now your whole negative 0.75 is shaded towards the right hand side over here. Okay, what does this mean, guys? This means they ask you to find the probability such that your z is more than negative 0.75. Okay, so from here how to proceed, guys? So this step is pretty similar to the previous example that I've discussed to you, which is example 3. So what you need to do, you need to convert this negative to the positive value, guys. So 1, the area under the graph. So what you do, you need to minus with the z is less than negative 0.75, guys. Okay, so equals to 1 minus probability of your z value such that is less than negative 0.75. Okay, proceed to the next step. So from here, 1 minus your q value 0.75. So this 0.75 you're going to find at the z table over here, guys, equals to 1 minus with, okay, how to find 0.75? Okay, let me teach you how to read in the z table. Okay, so as you look over here, the step 1, find the 0.7, guys. Okay, if you look here, this is your 0.7, but we still need to find the 5, 0.75. So the second number you find at the top over here, guys. Okay, 0.75. So intersect these two values. So from here you get 0.2266. So this will be your value of 0.75, guys. So you put that in your working. 0.2266. Okay, you calculate this. You should get your answer. Okay, let's do the calculation together. 1 minus 0.2266. So from here you should get your answer 0.7734. Okay. Okay, this is the last example we are going to discuss. Okay, most of the time the question will be asked you in this way, guys, where they will give you two z values. The one z value in the positive region and another z value is in the negative region. So in between these, you need to find the respective probabilities, guys. So how can you find this value? So in the question, they will always give you in this way, guys. So your probability in a bracket, negative 0.5 less than z less than 0.75. So from here, how to continue? Okay, let me teach you, guys. Okay, equals to 1. This one will represent the total area under the graph minus with your probability z more than 0.75 minus with your probability value z less than negative 0.5. Okay, equals to 1 minus q 0.75 minus with the q 0.5. Okay, so 0.75 you've already found in the previous example, example 4, so we can just write it straight away. 1 minus 0.2266 minus with the 0.5. Okay, 0.5 we haven't find yet. Okay, let us find this together. Okay, let us look at the Z table. Okay, as you can look over here in the Z table, your 0.5 value is 0.3085. Okay, let us write this value in our working, guys. Okay. Okay, you calculate this. 1 minus 0.2266 minus 0.3085. Okay, you calculate this, you should get your probability value is 0.4649. Okay, let us write this answer. So this is your final answer, guys. Okay.